Hi, this is Ryan. In this video, I'm going to take a simple character I created, Simple Dude, and start the process of setting it up for gameplay. I've already imported my skeletal mesh from Maya, so I'll start by creating the initial blueprints. A character blueprint. An Anim blueprint, driving the Simple Dude skeleton. A player controller. And a game mode base. Going into the character BP, select the mesh component and set the skeletal mesh and Anim BP. I'll move the character down and rotate it so it faces forward in the capsule. Next, we'll add a spring arm and a camera. I'm not going to worry about positioning the camera at this point. I'll do that later. We don't need to do anything yet in the Anim BP, so we'll leave that as is for now. Going into the game mode, set the player controller class to the new player controller and the default pawn class to the new character BP. For the game mode to take effect, we'll go to the level and look in the world settings. Set the game mode override to the new game mode. Once that's set, then we can hit play and see the new character in the level. It doesn't do anything yet, so now we can set up some inputs, so we can use a keyboard and mouse or a gamepad controller. I'll create a new inputs folder where I'll place all the input assets. I'll start by making 2 input actions assets. A move input action and a look input action. Then I'll create an input mapping context asset. Going into the move and look input assets, I'll set the value types to axis 2D. In the mapping context asset, I'll define the first key mapping using the move input action. Inside that, I'll define 5 mapping items. The first 4 being the standard keyboard keys for moving: W, S, A, and D, forward, back, left, and right. With the 5th item using the Gamepad left thumbstick, 2D axis option. For W, we need to add a modifier to Swizzle the value. The value comes in on the X channel, but we need it on the Y, and Swizzle makes that adjustment. For S, we also need to add a Swizzle modifier, but we also need a Negate modifier to give us the opposite value of W. For A, we just need to add a Negate value to give us a negative X value. And for D, we don't need to add any modifiers, since it's just using the default X value. For Gamepad, we want to add the dead zone modifier, which will help with getting rid of any drifting caused by the thumbstick. The second key mapping will be for the look input action. It'll have two mapping items. One for input from the mouse XY 2D axis. And the other for input from the right gamepad thumbstick, gamepad right thumbstick 2D axis. For the mouse item, we'll add a Negate modifier, but set it to only negate the Y value. The other two won't be negated. For the gamepad item, we'll add a Smooth modifier, which will help the movement look better. The next thing we need to do is to set up the player controller, which will add the mapping context so our character can use it. In the player controller, we don't need the event tick, so it can be deleted. We just need to use the event begin play. To start, create an Enhanced Input Local Player subsystem node. Searching for Enhanced Input Local should allow you to easily find the node. Once you have that node, then drag off the pin and search for Add Mapping Context. Attach that to the begin play and set the mapping context option to use our custom mapping context. The last step is to go into the character BP and set up the events so our inputs can move the character. In the event graph, look for our move and look input actions under the Enhanced Action Events category. After bringing in the two event nodes, split the action value pins so we can see the X and Y value pins. For the X value of the move event, we're going to use a getControlRotation and getRight vector function to figure out our left and right motion. We'll use an Add Motion Input node to set the motion value. Attach the return value of the right vector node to the Add Motion node. Then split the rotate pins on the Control Rotate and right vector nodes to expose the roll, pitch, and yaw pins. Just connect the roll and yaw pins. From the Move event, connect the X value to the scale value on the Add Movement node. Then connect the Execute pins. For the Y move value, we'll create another Add Movement node and connect that to the first one. We'll use a copy of the getControlRotation node, since the pins are already split. But this time we'll use a getForward vector node. After splitting the pins, you just need to connect the yaw pins. This will give us our forward and back motions. Connect the return value of the forward vector node to the second add movement node. Then connect the Y value of the move event to the scale value of the second add movement node. That should be it for the move event. The look event is a simpler setup. Create add controller yaw input and add controller pitch input nodes. Connect the execute pins, then connect the look event Y value to the yaw input node and the X value to the pitch input node. The character is now set up with basic motion inputs. To test it out, go to the level and hit play. We should now be able to look around and move the character in 4 different directions. One thing that's not working is looking up and down. We can look side to side, but up and down is locked. To fix that, select the spring arm component in the character BP. Then in the Details panel, make sure Use Pawn Control Rotation is checked. Once that's set, then we can look around freely. By default, the character is always facing the direction the camera is looking. This is the way I usually like it, but you can also make it so the character faces in the direction of motion. To do that, go into the character BP and select the class defaults. If you close all the categories, it will make it easier to find the ones we need. Look in the character movement, rotation settings, and pawn categories. The 2 settings we want to look at are Orient Rotation to Movement in Rotation Settings and Use Controller Rotation Yaw in Pawn. If Orient Rotation to Movement is checked off and Use Controller Rotation Yaw is checked on, then the character will face the same direction as the camera is looking. If Rotation to Movement is checked on and Rotation Yaw is checked off, then the character will face in the direction of movement. That's it. In the next video, we'll start adding some locomotion animation to the character.